Okay, this is a very hard titration question. So let's look at what we're told. We're told we have a white solid with sodium ethanodoioate in it. We've got ethanodoic acid, dihydrate. We've got an inert solid. And ultimately, we have to calculate the percentage by mass of the sodium ethanodoioate. Now we're given two formulas, so let's have a look at if there's anything we can spot in those. So one thing that's very clear is that there are ethanodoioate ions in both of those formulae. But one thing that's different about them is what they have with those ethanodoioate ions. So in one we've got sodium and the other one we've got hydrogen. So one is actually an acid and one is actually a salt. So they're performing two titrations, so we should consider there must be something different about those two titrations. They must be doing something different. So let's have a look at the first. And one of the things that should leap out sort of straight away is the fact that we have manganate 7 present, okay? And if we just look at the manganese itself and consider its oxidation number, well, it starts at +7 and it finishes at +2. So what this titration must be is a redox titration. Now, if the manganese is being reduced, then there must be something else being oxidized. And if we look carefully at that, we should notice that what's being oxidized are the ethanodoioate ions. So taking part in that titration is both the sodium ethanodoioate and the ethane dioic acid dihydrate. If we look at the second titration, as soon as we see the hydroxide, and as soon as we see the fact that we knew that we're starting with an ethane dioic acid dihydrate, then we must be having a acid-base titration here. So the two titrations are going to give us two different quantities. The first, the redox titration, is going to tell us how many moles of sodium ethanodoioate and ethane dioic acid dihydrate we have. And the second titration, the acid-base titration, is going to tell us just how much ethane dioic acid dihydrate we have. Now remember, the question is ultimately asking us to work out the percentage by mass of sodium ethanodoioate in the white solid. So if we think about the two titrations, titration 1 gives us the salt and acid, and titration 2 is the acid. So if we think about the difference between them, if we subtract one from the other, then we're just going to get the salt. So that's what we're going to need to do next. We're going to need to do the actual calculations based on the moles and volumes that we've got for titration 1, do it for titration 2, and then when we subtract titration 2's moles from titration 1's, what that will tell us is, give us an idea of, is how much sodium ethanodoioate, the salt, that we have. So let's look at titration 1 first. So we're given a concentration for the potassium manganate 7, and we're given a volume, so we can work out moles. So moles of MnO4 minus, which equals 26.5 over 1,000, because we've got to put it into decimeters cubed, times the concentration, which is 0.0200. So the number of moles equals 5.30 times 10 to the minus 4 moles of the manganate 7. And the ratio of MnO4 minus to the ethanodoioate ions, which is what we're titrating them with, and if we look back at the titration equation, is 2 to 5. So therefore, the moles of ethane dioate ions that are in this titration is 5/2 times our moles of manganate 7, which equals 1.325 times 10 to the minus 3 moles. So that is titration 1. So we can just draw a line onto that for the moment and move to titration 2, which is the acid-base titration, and we're given information about the hydroxide ions, so we can work out the moles of OH minus ions. So again, we're given a volume 10.45 centimeters cubed, but we have to turn it into decimeters cubed, multiply that by the concentration, and that gives us a number of moles of 1.045 times 10 to the minus 3 moles. So again, we've got to look at our ratios, molar ratios in that reaction, in that titration reaction. So the ratio of hydroxide ions to our ethane dioic acid is 2 to 1. So what that tells us is that the moles of ethane dioic acid must be half the number of moles of hydroxide. So 1/2 times 1.045 times 10 to the minus 3 equals 5.225 times 10 to the minus 4 moles. So we've done the calculations for the 2 titration questions. So even if we were sort of stuck as to what to do next, we would have probably got 3-4 marks out of this question. So as scary as it looks, getting at least half marks hopefully shouldn't be a problem. Anyway, so let's just think about what we've done. We've done the titration of, the first titration looks at the moles, and that's the number of moles of the ethane dioate ions, and that they come from both the sodium ethane dioate and they will also come from the ethane dioic acid dihydrate. So the difference between the 2 titrations is essentially giving us information about the sodium ethane dioate. So let's subtract the moles from the calculation for titration 2 from the moles that we calculated in titration 1. Okay, let's just draw a line. So 1 minus 2 is equal to 1.325 times 10 to the minus 3 minus 5.225 times 10 to the minus 4 equals 8.025 times 10 to the minus 4 moles. And this, remember, just got to pay absolute attention to the fact that we were doing both of these titrations referred to a volume of 25 centimeters cubed. But the original solid was made up of 250 centimeters cubed. So the actual number of moles in the original solid of the sodium ethane dioate is going to be 10 times what we've just calculated. So moles of Na2C2O4 in original sample is equal to 10 times, because it was in 250 centimeters cubed and we only titrated 25 centimeters cubed, times the value that we just worked out, equals 8.025 times 10 to the minus 3 moles. The MR of sodium ethane dioate is 134. So that means the mass, remember, is moles times MR. 8.025 times 10 to the minus 3 times 134 equals 1.075 grams. This was 1.075 grams in the original 1.9. So our percentage is our actual over our maximum. Okay. Let's just remember that we had to do it to the appropriate number of significant figures at the bottom. It says that in the question. All the masses are to 3 significant figures, the concentrations to the 3 significant figures, the volumes are in the titra are to 4 significant figures, but we go with the smallest, so it's 3 significant figures. So we end up with 56.6%. And that is the answer to our question. If we get that far, we've got 8 marks. So hopefully that was clear. It was my first go at using this app. So if you've got any comments or suggestions or anything, and I was learning a little bit as I went along anyway myself, so I'm sure I would do certain things a bit differently. But anyway, if you could let me know, that would be great. Thanks very much.